All right, we're going to be looking at this Ferris wheel problem right here. What we're going to be doing is starting to graph sine, cosine, tangent, seeing how all of that works. And we're going to do it from first this perspective of this Ferris wheel. On top of that, you should also keep handy while you do this work a decent image of the unit circle. And I'm going to just open one up right now that I can keep in a tab. That's not... There we go. Not the best definition, but it'll work for our purposes. Okay. So as we go through this, we're going to consider this Ferris wheel below, label all the seats with the appropriate degree and radian measures. So let's start with that. Let's start with degrees. Now, with the unit circle, and when we were doing that, we would always start right here. So we're going to start right here, 0. And then right up there would be our 90 degrees. So notice it's chopped that 90 degrees into 3 sections. So 1/3 of a 90 is 30, 60. So we're going 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and I know I did it right because I just ended my circle on a 360. All right, next, let's get those radian measures in there. Okay, so the radian measure is going to start at 0. And then we also know that it goes to 2 pi. And a lot of these I would just be taking off of the unit circle. Okay, now you can see where 30 degrees is. That's a pi sixth, then pi thirds. And so I'm largely going to be using a unit circle to figure this out. So pi sixth. For some reason I can't write pi right now. Then we got pi halves, 2 pi thirds, 5 pi sixths, pi, 7 pi sixths, 4 pi thirds, 3 pi halves, 5 pi thirds, and 11 pi sixths. All right, so I've got all my radian measures in there. Next, it says that the radius of the wheel is 10 meters. All right, so let's just put a 10 right there. And that the wheel is 2 meters off of the ground. And it wants us to figure out the height of each seat. Well, there's some that are going to be easy. So first, this one that's barely off the ground must be 2. Now if the radius is 10, so if I come up here to the middle, that must be 10 more. So I would be up at 12 there. And then from there, we can go 10 higher. So right at the top is going to be 22. Now for the rest, we would need to use special right triangles. So for example, this one down here is a 30 degree. Now, if you remember the lesson from special right triangles, you could use that method. Actually, what I am going to use is I'm just going to use the the unit circle that we already have. Because the unit circle has already told me what the x and the y would be from a triangle like that. So I know from this it would be like a square root 3 over 2, and that would be a 1/2 right up there. Now the unit circle has a radius of 1. So what do I need to do? To make it match this and for us to figure out how much height it has, I just need to go from a radius of 1 to a radius of 10. In other words, make everything 10 times bigger. So that 1/2, 10 times bigger than a half, is 5. 10 times bigger than square root 3 over 2 is going to be 5 square root 3 over, or 5 square root 3. Because essentially the 10 times the half in that was 5, so we're just left with 5 square root 3. So we can see that the height off the ground there is going to be 5. So 5 above the 12 would be 17. Well, this guy's the same height, so he should also be 17. Well, and this is also another 30-degree angle right there, just going lower. So I need to be 5 below that. So that's going to be a 7. Okay. Next thing with this is this triangle that I've already drawn is actually a 30, 60, 90. So to get this angle right here, that whole thing is actually a 60 degree. So the height of the 60 degrees is just our 5 square root 3. So for an exact answer, we would just do 12 plus 5 square root 3. But I'm going to go ahead and get an approximation for that. So that's going to be about a 20.7. Which means that we're just adding about 8.7. So we add an 8.7 here, get a 20.7. Now that's what we added also to get these ones down below, minus that 8.7. So we can do 12 minus 8.7, and we would get about, this is 3.3 above the ground. Okay, all right, so I figured out those numbers. Let's go ahead and get those put into this table. So first we need to start filling in those radian numbers for the seat. So 0, pi divided by 6, pi thirds, pi half, 2 pi thirds, 5 pi sixth, pi, 7 pi sixth, 4 pi thirds, 3 pi halves, 5 pi thirds, 11 pi sixth, finally 2 pi. All right, so I've got all my radian measures in there in order. And now for the exact heights. Now some of these were already exact, but we're going to start here at the 0. It was up at 12. Then we started going up, and the next one at pi over 6 was 17. Now this one we rounded, the 20.7. The way we figured it out, though, is we went from our middle one here, the 12, and we added in the 5 square root 3 from our special triangle. Okay? And then at the top we had 22. Then we came back down to the 12 plus 5 square root 3. Back down to a 17 again, to a 12 again, and now we're going lower. So then we'd be at 7, 3.3. We reach the bottom of the Ferris wheel at 2, Then we start going back up. Oh, oops, I forgot to do exact answers. So those 3.3s, those were actually where from the 12 we had gone down 5 square root 3. To make sure I'm putting in the exact numbers. Then we're back up at 7, and then we've come all the way back fully around the Ferris wheel, and we are back at 12. A lot of these are just going to be the exact same numbers, except for where we got the 5 square root 3. We're going to approximate it to 1 decimal point. Um, 12 minus 5 square root 3. So that at the minus, that was a 3.3 to 3.3 back up to 7 and 12. All right, so now that's how we've completed the table and figured out all the numbers on our Ferris wheel. So let's look at some of these questions. What's going to happen to the height as you continue to rotate around the Ferris wheel? Well, these black numbers are our heights, so as I continue, so I was at 12, now I'm going to go to 17, to the 20.7, to 22. I'm just going to repeat all the exact same numbers over and over. Because that's what you do. The Ferris wheel just goes around and you reach all the exact same heights. So I'm just going to put a really simple answer here, and I'm just going to say they repeat. At what other angles would your seat be at the same height as the 30 degrees? Well, same height as 30 degrees was right over there at 150. What will your height be when your seat is at an angle of 3,000? So what happened here is we went all the way around 360, all the way around again 720, all the way around again 1,080, and we kept on repeating a process of going 360 plus 360 plus 360 until we finally reached an amount that was really just 3,000. So if we want to figure out how much the 3,000 was, what we can do is minus a 360, which is going to give us like 2,640. That's still too big. Minus another 360, and just keep on doing that till we finally reach some number, some standard number that we could see on this. It's going to be a number between a 0 and a 360. All right, and so that's what we would do. 3,000 minus 360. And we're just going to do it over and over and over till we find what that equals. It ends up being 120 degrees. Okay, all right, so 3,000 degrees is actually just, we've gone around so many times, but then we went to about 120. So the height right there is going to be 20.7. So our answer, 20.7 meters high, is how high you're going to be after you've gone 3,000 degrees. What would happen to the heights if the Ferris wheel started rotating in the opposite direction? All right, well, let's think about that. If we're starting at 12 and we start going the opposite direction, we then go to 7, 3.3, 2, 3.37. So notice what we've got right here, 12. We would see all those same numbers, but we're going to see all these numbers just backwards. Okay? But notice this 12 that we have on our thing came from the same place as the other 12, right at the beginning. That 0 and 2 pi are the exact same location. So we are just seeing these same numbers when we start from that same location, but we're seeing them happen backwards. Okay, so if you go in the opposite direction, you get the same numbers, just backwards. All right. Now, this 1920, this is very similar to D. These two are very similar. This one is assuming that we did go backwards. We went backwards 1,920 degrees. in order to figure out how much that is, I'm just going to start adding in 360s until I arrive at a number that I can find, some number that is between a 0 and a 360. And that's going to come out to 240. So the height at 240 is 3.3. So 3.3 meters. All right, so now let's talk about graphing this. Okay, now I've gone ahead and labeled these. Notice I didn't label with your normal 1, 2, 3, 4. Rather, I labeled it and I used the radians that I counted by up here. So we got 1 pi 6, 2 pi 6, which would just be pi thirds, 3 pi 6, which is a pi halves, 4 pi 6, 5 pi 6, 6 pi 6, which would be a pi, 7 pi 6, 8 pi 6, 9 pi 6, which simplifies to a 3 halves. And that's essentially the way this is counting. And it's going to make graphing those points a bit easier. Next part of this, I need to figure out how to label my y-axis. The highest number we went up to was 22. So if I count by 2's on this, I should be able to get high enough. So I'm going to count 2 is the first line, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so I know my graph goes high enough now. All right, so let's start out at 0. At 0 degrees, we were up at 12. So that'll be my first dot. Then at pi 6, we were up at 17. And then at pi thirds, we were up at 20.7. And then at pi halves, we were up at 22. And then we started coming back down to the same 27ths, 17, 12. I hope you notice, once you get a few numbers and you know the spacing in between each of them, it makes it kind of easy to draw. Okay, then from there we went down to a 7. After the 7, at a 3.3. Then we were down at 2. Then back up at the 3.3. The 7. And then we ended back at 12. And then after that, we just keep going up. So our next number should be back up at about 17. Okay, but what if we went backwards? Once again, same numbers, just opposite order. So if we started at 12 and the thing went backwards and we went a negative pi 6, then we would be down at the 7. And then we'd continue down and be at the 3.3, then at the 2, then we'd be at the 3.3, up to the 7, and then we'd finally be up at the middle of 12. After the 12, we'd then go up to the 17, then to the 20.7. We'd reach our peak at 22 and start coming back down to 20.7. Looks like it's starting to struggle with writing. Or at least right there it is. But hopefully that's enough to get your gist. I'm sorry, it stopped allowing me to draw circles over there. It only is randomly letting me get some of those now. But yeah, so that's how we graph this. Now, this is a periodic function. It has a clear pattern to it. The pattern is going to repeat because we just keep going around that same circle, and we're going to keep hitting those same exact numbers. Okay. Now, let's see a somewhat simplified version of this one now. So what would the graph look like if the radius of the Ferris wheel was 1 unit and the center of the Ferris wheel was at the origin? So right here we've got ground level. So that's 0. This new Ferris wheel just has a radius of 1. So at most it goes 1 up and 1 down from there. Thinking about the special triangle we had before, the 30, 60, 90, that had a half and a square root 3 over 2. That's going to help us to do some of these angles in here, like the 30 or the 60. Okay. And so, in fact, let's go ahead and fill those in. So this first one, or even easier, if it has a radius of 1, then it's all those same numbers as what we would get from the unit circle. Now remember, this time we're talking about the height. Y values tell us what the height was. So the height at 30 was a half. The height at 60 was the square root 3 over 2. And because both of these now have a radius of 1, they are the exact same numbers. So I'm going to have this be a half square root 3 over 2. This one's that same height, so square root 3 over 2, and then a half. Well, now we're going below ground, so we'll now be at a negative a half, a negative square root 3 over 2, another negative square root 3 over 2, another negative 1/2, and then we're back up at ground level. Okay. All right, and so let's go ahead and start getting those heights in. So at 0, we start at 0. Then we went to 1/2. And then the, come on, square root 3 over 2. And then up at the top at 1, coming back down, we'd be at square root 3 over 2. I'm sorry, it's not writing anymore. This is already a 20-minute. Okay, I think I got it figured out. For some reason, it doesn't want to do any writing on the far left side of my screen. Hopefully that's the only issue, so that this can continue. Then we got negative half, negative square root 3 over 2, negative 1, negative square root 3 over 2, negative half, and then up to 0. 0.5, and then a square root 3 over 2. Should be about a 0.87 or about a 0.9. Zero, and then we're at negative 0.5, negative 0.87, negative 1, negative 0.87, negative 0.5, and then up to the 0. All right, so now let's look at the graph that they want us to try to make. So let's go ahead and start to do this graph. So starting first at 0, then at our pi 6, let's also figure out these heights. The biggest I ever go is, and the lowest I ever go is 1 and a negative 1. So I'm just going to go ahead and label this that way. So I really make use of my y space. All right, so it first goes up to a half, then approximately to a 0.9, then at pi halves we're at 1, 0.9, a half. By pi we're back down to 0 because we've gone halfway through, then a negative 0.5, almost a negative 1, actual negative 1, and then we start coming back up that circle. Going behind us, it would be that same pattern. It's already going down. The next would be, we'd go down to the negative 0.5, then the negative 0.9, negative 0.1, negative 0.9. We're going to start coming back up the Ferris wheel. Negative 0.5, 0, at 0.5, 0.9, 1, 0.9. Now we're going to start going back down because we reached our peak at 1, then a half, and then back down to ground level. Now, this graph is y is equal to sine of x. This is how we graph it. Now, of course, definitely I went a bit intense with all of that graphing. We're not going to make you do that quantity of work, but I want you to know that and firmly establish in your brain that when you're just talking about the height off the ground of something that is circling around, that's really just what sine is doing. So in this case, x is representing our angle, and the y is representing the height. All right, so if you are given sine of x and asked to find sine of 30, what you're really asking is to find the height at that point. Okay, so sine of 30 would be the height, which is a half. Now, sine of 390, we would go all the way around the circle, and then that would be 360 degrees. So to get to 390, I need to go 30 more. The height at that is also a half. Oops. Okay, and then at negative 330, so if I go backwards 330 degrees, so notice 330 degrees positive is just, I would have started at this line and gone almost nearly all the way around with just 30 degrees left to go. But to do it the negative direction, we'd go almost all the way around, just 30 degrees left to go, and the height is at a half. And even for this 690, this negative 690, we can just keep adding a 360. And as we keep adding 360 to 690, guess what you get? You get that it's the same as 30 degrees. So that's at a half. If we do this 2 pi thirds, so 2 pi thirds on here, let's see, there's the 2 pi thirds. The height off the ground is a square root 3 over 2. And 8 pi thirds, well, that's bigger than even a 2 pi. So I would need to subtract out 2 pi. Well, 2 pi is not a fraction, so that makes it tricky. So I can multiply top and bottom by 3 and get a 6 pi thirds. Notice 6 divided by 3 is still 2. So it's still a 2 pi. So as I subtract out that circle, I get 2 pi thirds. Same exact thing. Square root 3 over 2. And I would continue that. This negative 4 pi. Sweet. It's also a thirds again, so I already know what to do with that. I could add the 6 pi thirds that I got from the previous one, and look, it would also go to 2 pi thirds. So a negative 4 pi thirds, once we go all the way around the circle again, is really just the exact same location. All of these are what you call coterminal angles. You can find a coterminal angle by, if you're using degrees, add or subtract to 360 over and over and over. All of those angles will be coterminal. They take you to the exact same spot. If you're dealing with radians, add or subtract a 2 pi. That takes you all the way around the circle, and you're in the exact same spot. Okay. All right, in this next one, we're going to label our XY axis. We're going to use the center of the Ferris wheel as the origin. We're going to label the seats with appropriate radian measures. We already did that in the first one, so I'm not going to redo that. But what we're going to do with this is we're going to look at how far each seat is away from the y-axis. So here's our y-axis. How far away is each seat? Now the radius is once again just going to be 1. So we can still use our unit circle. And if I want to know how far away from the y-axis it is, that's just an x value. Okay? How far did I move away from y? Well, that's my x value. So like square root 3 over 2. So this one, I've gone a full 1 forward because that's the radius, or I've gone a full 1 back. If I'm on the actual axis, I'm not away from it at all. And then using my unit circle, I can also figure out that must be a square root 3 over 2. That'll be a 1/2. Now I'm behind it, so that'll be a negative half. Negative square root 3 over 2. This is the same distance behind the y-axis as that up above. Then we'll be at a negative half. We've now reached 0, so now we're going in front of the y-axis. And there we go. You'll notice pretty much the same numbers. One of the big differences is where did we start? We started at 1 this time. But I can go ahead and fill in this table pretty much the same. Oops, negative square root 3 over 2, negative 1. Zero, and now we're going forward. And we've reached the very front again. And once again, a square root 3 over 2 is just about a 0.87. But notice, we were going backwards until we reached all the way back at negative 1, and then we just started going forwards again. Very much the same way as when we thought about the Ferris wheel taking us up, and then back down, and then back up again. All right, so what's going to happen to the displacements from y as you continue to rotate around? Well, that's like the first question before. It's all going to repeat. What will your displacement from the y-axis be when you're at an angle of 3,000? Remember, that was just the same as 120. So at 120 degrees, our displacement is going to be a negative half. What would happen to the displacements if we started rotating in the opposite direction? Well, let's think about that. So first, we started out at 1, went to a square root 3 over 2, then to a 1/2, then to a 0. If I go the opposite direction, I'll go to square root 3 over 2 to 1/2, and then to 0. Those are the same numbers. So actually, I'm going to get the exact same numbers, not even backwards, just the exact same numbers because of the way that this one worked, that we started out at that peak of 1 rather than starting out at 0. But because we started out at the peak of 1, there's only one place to go, and that's lower. Whereas before, since we started out at 0, yeah, we could go up, or if we went backwards, we were going to go down. What will your displacement from the y-axis be at negative 1,920? That was just a 240 angle. Our 240 angle would be, we will be displaced by a negative half. Okay? Oh, same as the other. All right, so we're now going to use that information from the table to start making our graph. We're going to once again go up to a 1 and down to a negative 1. So this time we started all the way up at 1, then at pi over 6 we were down at a 0.8, then we went to a 0.5, 0, negative 0.5, negative 0.8, negative 1, negative 0.8. Now we were going forward again, 0.5, 0, 0.5, 0.8, and then we were all the way forward at 1. Going backwards, it's those same numbers, just repeating. This is going to create a perfect reflection around the y-axis using those same numbers. Now this graph that we have just created right here, by focusing in on how far forward or how far backwards, because that's where all these came from. This went square root 3 over 2 forward. That went a half forward. That went a half backwards. This gives us a new graph. This new graph is what cosine is, focusing in on the x's. Once again, these were the angles, but the y represented a y-axis displacement, or in other words, how far away were we from the y-axis? And if we were behind it, then we showed that as a negative. Now that's the cosine. All right, now I'm going to finish up these notes here. I'm going to give you a few suggestions on how to finish those graphs. The sine and cosine graph waves are very similar. So I want you to figure out, what are 3 similarities? State one of the differences. So we are talking about this cosine graph and this sine graph. What are the similarities? What are the differences? And state one difference. Next, it's going to ask you to graph. Now, we just took a long time to make those other graphs, and now this assignment is showing 3 of them. The work we've already done actually makes this work easier. Okay? So you just need to pay attention to how these transformations are going to affect it. So notice we've already graphed a sine, and this is just sine plus 3. Well, what is the plus 3 going to do? It's going to take all those numbers that we got for sine and just add a 3. So we could use all these same numbers, but just add 3. How would that affect our graph? Well, all those dots would just be 3 higher. So if I were looking at that table that I've already made in this graph, I could say, all right, well, if this is counting just as 1, 2, 3, I started out at 0. Well, 0 plus 3 is 3. And then I went up to a, for sine, I went up to a half, so then I'd be up at 3.5. And then I'd be up at a 3.8. And then I'd be up at 4, because 1 plus 3 is 4. I'm just moving all of those dots to be 3 higher. And I can start getting a graph. And notice it did not take a huge amount of work. It just took some thought. This next one, we're adding a pi sixth, but inside where x was. if you remember the parent function project, that would take us to the left. So everything would be to the left pi sixth. Well, how are we counting? It went from 0 and then the first number was pi sixth. Well, that's a single square. So everything would be a single square to the left. Okay? Down 2. If you're multiplying everything by 2, everything will be 2 bigger. So rather than it going up to 1, 2 times 1 is 2, this one will go as high as 2. So you can use thinking like this of our basic transformations to then finish these graphs. Or if you're struggling, then I'm sorry, you're going to need to go and make a table of values by plugging all your numbers in to a calculator.